We've seen how to create objects from both classes and subclasses. Let's now use subclasses to make an interesting project. Here's an aquarium made up of a bunch of fish. The little yellow fish is glowing with light. It tastes delicious, and it's connected to my mouse. The hungry fish have wide open eyes and a big smile, and they want to eat the yellow fish. The sleeping fish ignore it, and they just swim back and forth. Every fish in this aquarium is its own object, and it takes care of everything for itself, including how it moves and how it looks. In fact, all three types of fish, the yellow food fish, the hungry fish, and the sleepy fish, are all subclasses of the same single class, representing a fish. The beauty of this approach is that everything shared by the subclasses, like the shape of the fish and the way it moves, is in the superclass. Each of the subclasses just represents what's special about that kind of fish. Here's the way the program is built. The project is called Aquarium, and it is super simple. The main setup routine creates the graphics window as always, and then it creates one object, the fish tank. That's it. Then the draw routine tells the fish tank to draw itself and update itself. And that's it for the main routine. The fish tank contains a list of objects of type fish. Actually, it contains a list of objects that are subclasses of fish. Some are hungry fish, some are sleepy fish, and there's one light fish. These 5 classes make up the whole project. So let's look more closely at the classes, starting with the fish tank. The tank has 2 instance variables. The first is an array of fish, which I call fish list. There's also a separate variable for the little yellow light fish. That's to make things easy for the hungry fish, and we'll get to that in a moment. The first thing a fish tank needs, of course, is a constructor. We take in the number of fish as an argument, and we create an array that is big enough to hold that many fish. Then we run through a loop and create a new fish for each entry in the array. Finally, we create a new light fish, and that's all the constructor needs to do. On every frame, draw first calls the fish tank's update routine. All this does is send the update message to every fish in the tank, all the fish in the array, plus the light fish. Also on every frame, draw will tell the tank to render itself. So the tank first draws the blue background of water, and then it tells all the fish in the tank to draw themselves. First the fish in the array, and then the light fish. And that's all it takes to create a fish tank. Since the tank is made up of fish, let's now take a look at the fish class. The fish class is responsible for everything that all the fish have in common. Like most classes, it starts with a few instance variables. Here, it's the fish's center and size, or radius, as well as its color and speed. I actually use the speed to also tell me which way the fish is looking, since it's always looking in the direction it's moving. So if the speed is positive, the fish is looking to the right, and if the speed is negative, the fish is looking to the left. As always, our first job is to make a constructor. Here's a very simplified version of the constructor, where I'm even leaving out the types of the arguments. All the constructor does is save the 4 arguments in the 4 instance variables. We know that the fish tank will call update and render for every fish. So let's start with update. Update just adds the fish's speed to its horizontal location. If the fish is about to go off screen either on the left or the right, we call a routine called flip direction to turn it around. And we'll see that function in a second. Now we have the render routine. My default fish is centered at 0, 0, and it has a radius of 1. So all the x and y values are between -1 and 1. So to draw a fish on the screen at a nice big size, our first job is to translate to the right position and then scale so that the fish shows up at the size we want. As we saw in an earlier video on drawing with subclasses, I gather all those transforms together in a little routine called do transforms. Once do transforms has us in the right place at the right size, I fill with the fish's color, and then I draw a closed Catmull-Rom curve for the fish's body. Then I switch to black, and I draw a little black dot for the eye. I referred to two little routines we haven't seen yet. Do transforms is responsible for translating and scaling the coordinate system. I also check here to see which direction the fish is heading. My default fish is pointed to the left. So if this particular fish has a positive value of speed, then it should be pointing to the right. So I include a call to scale the x-axis by -1. This mirror flips the fish left to right, so it's pointed to the right. The routine flip direction does just what we've seen before in our examples of bouncing balls. We reverse the direction by flipping the sign on speed, so if it was positive, it's now negative, and vice versa. Then we add double the new speed to the fish's horizontal position, so it doesn't go past the edges of the window. This class does everything a basic fish needs to do. It swims by advancing forward every frame at its own speed, and then it turns itself around when it hits the edges of the aquarium. And it draws itself in the right position, at the right size, in the right color. Here's an example of our fish tank filled with nothing but these basic fish. Each one is created with random values for its starting position, size, color, and speed. From then on, it's every fish for him or herself. Every fish is an independent object, and it takes care of itself independently of all the other fish. Let's now make things more interesting by introducing 3 subclasses of fish. First up is the hungry fish. This fish has a big open eye, a big hungry smile, and a desire to be facing the yellow light fish. It doesn't need any new variables because the parent fish knows everything that this fish needs to know. So we can start right away with the constructor. And the constructor is just about nothing. It takes the 4 variables that describe a fish and it hands them to the fish superclass's constructor. That's it. As before, to keep things short here, I've left off the types of the arguments. What makes a hungry fish special is its behavior. So a hungry fish will do everything a normal fish does, like swim and bounce off the edges, but it does more. So the first thing we do in update is we call super.update. That way, the parent fish class can take care of moving the fish and flipping it around if it bumps against the sides of the aquarium. But then a hungry fish will do more. It will compare its position and direction with the position of the light fish. This is why I keep the light fish in a separate variable in the tank object. It's to make it easy for the hungry fish to get at the light fish's description. So a hungry fish asks itself, am I looking at the light fish? If it's not, it calls reverse direction to flip itself around. Remember, this is the routine reverse direction that lives in the parent class. Only now, instead of letting the parent call it when we hit the side of the tank, we're calling it, so we're always looking at the light fish. Finally, a happy fish renders itself by first asking its parent to draw itself, and that gets us the fish body. And that also draws a little black circle for the fish's eye. So I call do transforms to get it into position, and then I draw a Catmull-Rom curve for the mouth. Then I draw a couple of new circles for the eye right on top of the eye the parent drew. That wraps up the hungry fish. Now let's look at the sleepy fish. This fish is just about our generic fish, only it has a different eye and mouth. So it doesn't need any new variables, and the constructor is just like the one we just saw. It takes the 4 arguments we need to make a fish and hands them up to the constructor for the superclass. This fish does have a different eye and mouth, though, so it needs a new render routine. First, I call the parent's render, as always, to draw the body of the fish, and also the eye. Then I push the matrix and call do transforms. I draw a closed Catmull-Rom curve for the mouth, and then I draw a couple of circles over the existing eye to create the little sleepy eye. That wraps up the sleepy fish. All that's left is the light fish, and that's easy. The constructor here is the same as all the others. There's no new render routine because the generic fish looks just fine for this little fish. But we do need to change the update routine because this fish doesn't swim on its own. Instead, the fish's center and Y are simply the current values of the mouse X and Y. That wraps up the architecture for this project. In part 2, we'll put all of this together, and then we'll see how inheritance lets us easily make everything look better.